When it comes to system design interview, interviewer can ask you a question about their application security, and not only about the application, the way your application is communicating over the internet. So for that, here we have few questions which for this particular topic, interview can ask the question, and I want you to go through all these five questions, stop the screen, and try to answer these as well. And then we will go for the concept. If you know all these answers, then you can simply skip it. So I want you to stop the screen and just try to answer these questions. Okay, I guess you have went through all these questions, and if you're not able to answer them, then don't worry. For that, I'm here. So I will take you to the concepts, then we will come back here to these questions. Okay, so here what I will do, I will come to the representation screen, and here we will start the uh, what we will say, the knowledge. Okay, so here, first of all, to understand this, how HTTPS work, how this TLS handshake work, and what are these SSL certificates, we need to create a platform over which we can talk about it. So first of all, we will create the setup. Okay, so for the setup here, I have this user and I have this web application. Let's say this user and this web application is connected over the internet, and the user is using either their phone or their laptop or any device which can be used to access this web application. So user is using these devices, and these devices are connected over the internet to access the web application which is running on some server. Okay, so till now, till the last lecture, we understood that first of all that there are one channel create between these two. And what are those channel? Those channel might be, okay, so it is the pipe. This pipeline will be created between the user and the web application, and that pipeline is TCP or QUIC. TCP is the older one, but it have the new versions as well. And this QUIC is the one which was created by the Google to connect the user to the web application, and it have its own advantage. TCP is more secure and more reliable. QUIC, on the other hand, is very fast. Okay, so currently this user and web application are connected to each other with the pipe, which have the TCP or QUIC. But still, there is something missing. And why? Because these two things will take the data uh, in non-secure mode. In non-secure mode. It means if there is any hacker which is standing like a vigilant, they can hack this pipeline and get the data. And this is not a good thing. So for that, what this internet did, this internet created TLS. What is this TLS? TLS is the one which provide a security over this pipeline on which your server or your phone is connected to each other and sending the data from phone to the web application or from the web application to the phone or mobile or laptop. So how this TLS work? Like how this TLS work? So for that, the one thing what I can say in a very short way, whenever you go to any website, either in a Chrome browser or any browser, you will notice that there is one HTTPS, then colon, and slash slash, and then the site name. This HTTPS is because of the TLS. If you don't find this HTTPS, and let's say is only HTTP is there, then it means TLS is not enabled in that communication between the user and the web application. So sometime when you open your web browser and try to access some application or some web application, you will see there is one screen comes to you, and that is called as not secure. that it will show you that this site is not secure, and on the URL section you will find that there is a very red mark there in the Chrome, because that site is not secure and any hacker can take your data from there. So that is not good. That is why you should not access any website which is not secure or which do not have the HTTPS. So it is just the role of HTTPS and TLS. But how does TLS work? Okay, so for that, what I will do, I will just drag down a bit and we will start from the TLS handshake. Okay, so first of all, actually we have two type of communication between the user and the web application. So the one is, okay, let me go back to the pen. Okay, so the one is TCP and second is QUIC. So these are the two ways in which your application can be connected to the user, but they both need to perform the TLS action so that they can be secure. And for both the mechanism, the TLS integration is different. Okay. So for this TLS integration, actually we call it as a term as TLS handshake. It is called as TLS handshake. So for the TCP, uh, so first we will talk about the TCP. Okay. So here is the TCP, and I will just drag down a bit. So here is the TCP, and we will start with the okay. So when there is a user and there is a web application, or let's say web server, they are connected to each other with the TCP protocol. Okay, this TCP protocol is connecting the user and web application, and we need to secure it with the TLS. So what happen is, first it will send the request of TCP. First, the TCP handshake will happen between user and application. Then the TLS handshake will happen between the user and application. So it means, so for the TCP, earlier we understood that it will use 1 RTT, round trip time. So it is the round trip time means to establish this connection, it will take 1 RTT. And let's assume this 1 RTT is of around 200 millisecond. So it means this in this 200 millisecond, this TCP pipeline is created between user and the web application. And same goes with the TLS, it will take the 1 RTT. So if a user is connecting to the web application in the secure mode, then it will take around 2 RTT. 2 RTT means 200 milliseconds. We are assuming this 1 RTT is 200 milliseconds, and this 200 milliseconds multiplied by 2 equals to 400 milliseconds. So we understood one thing, that for the TCP and TLS, it will take around 2 RTT, and we are talking about the latest version of TLS. So let's not go for the old one. We are not talking about the garbage thing. We will just focus on the latest thing. So here we have the 400 millisecond for this handshake, and okay, so it is just the calculation of time, that how much time it will take. But still we are not there where we can understand that how this TLS work. So to understand this TCP and TLS, we will okay, let me just drag down again and let me write it here again. Okay, so here is the TLS for TCP. Okay, so let's not assume it is the fact that here is the client. Client is what? Client is user. And what user is doing? User is using some machine. User is using some machine. This machine can be phone, any PC, or any device which can use the internet to access the application. And here is the web application. This web application is running on web server. This web server is also a machine. Okay. So for the client and web application, we need to actually connect these two machines. Okay, so we need to connect these two machines over the internet, from where they can transfer the data to each other in a secure mode. So for these two machines to be connected to each other, there should be some mechanism so that these machines can understand then, okay, I have, let's say, for a general example, when you are going to access your Facebook account, what you do, you provide your username, you provide your password, and then you are able to log into your Facebook account. And same goes with the Facebook, because the Facebook have the data of your email ID and your password. And when you provide that username password to the Facebook portal and the Facebook was able to match that data to its database, then only this Facebook allows you to go inside that account which you are trying to access. Same mechanism goes with these machines as well. So what these machines do, over the internet, there is no mechanism of providing username and password. What they do all the things in the backend where user don't actually understand what is happening. But these concepts need to be understand uh, in a way so that we can answer the questions when we are at the interview. Okay, so so here we need to connect these two machines, and to connect these two machines, there is a concept of public key and private key. What are these two things? These two key, actually, these are the files. These are the files, not files. It is a single file. And what these file contain? These file contain encrypted machine data. Okay, so now we need these public key and private key where this encrypted machine data is available. Okay, so for that, what I will do? Okay, so the one thing which I understood, that there are some certain files which contains the data of machine, and these actually these encrypted data is are providing the way to access that machine. Okay, so because of these file, anyone can access that machine over the internet, but still it is not connecting like what we are trying to say here. Okay, so for that, what I will do, I'll just try to explain it a bit more. So first of all, let's say here is your machine. Here is your machine. It is your PC, and your PC is available over the internet. It is in the internet. So for someone who is also inside the internet and they are trying to access your machine, what they need some user ID and password. Again, it comes to the user ID and password. User ID, password, machine details. These three things the second person need. The second person, uh, there is one person which is I'm calling as second person. The second person need these three things: user ID, password, and machine detail to access this machine, which is my machine, and it is available over the internet. So what I did is I created the file. I created the encrypted file. I created the encrypted file, and these encrypted files are public files and private files. Private file. For the technical perspective, just remember it as a public key and private key. Okay, so I created the encrypted data of this user ID, password, and machine detail, and these details are available over the public file and private key file. Public key file and private key file. First of all, there's a very simple thing that how you generate this public key file and private key file. So for that, what you have to do, all you need to run is this SSH keygen command on your terminal, whatever the system you are using, and it will prompt you few questions. And when you provide the answer of those questions, that where you want to create these files in your directory structure and what other details you want to provide. After providing these all details, it will create two files, and these two files will be okay. And these two files will be one will be .pub and other one will not have this .pub. It means this will be the public key, and the second one will be the private key. Okay, so I got these two files with this ssh keygen command, and these two file contains the data of my system, like it because of some id, whatever it is asking, it will provide the id, password, and all the machine details which can be used to access this machine over the internet. But how it work actually? So to work, what we need is uh, it is the first person. It is the first person. Okay, let me just go for the green. And it is the second person. This private key work as a password, and this public key work as a, what you can say, work as a identifier, or work as a lock. You can say lock. So every lock have some key to unlock it, and this first person, it was the system. So what it did, it created a shield of this public key. It is a lock. It is a lock, and the second person have the private key. So what the second person will do, second person will send the private key to the system. This public key will get the private key, and actually it is a key to that lock. It is a password to that lock. So uh, it will unlock this connection, and it will let the second person to enter in this machine using the private and public key without using any another another keys or another data. All this second person need was the private key. So we understood that what is the concept of public and private key, what is the concept of public key file and private key file. This private key file contains the data which will be used by the public key file to let the connection, uh, so to let the data enter into my system where this public key is present, or where this public and private key is created. So it is the one concept which is used for the TLS handshake on the TCP. Now we will connect all these dots to understand that how this TCP use this TLS handshake in its connection. Okay, so I will just drag it down. Okay, so let's go for a fresh screen. Fine. So again, what this will do, here is the user, or you will say client, and here is the web server. Let's assume this user is using some machine, and I'm referring that machine here right now. And this web server, by its name, it is a server and it is a machine. So they both will create this public key and private key. Public key and private key. And what they will do, web server will send the, when user will try to get data or try to connect with the web application, this web server will share its public key to the user. It will share the public key. What this user will do, user will use this public key, and what it will do, it will do the, okay, it will create the symmetric encryption. Currently, this public key is available to the user, which is of the web server. It is the web server and it is the user, and they both have created public key, private key, public key, private key, and this public key can be shared to anyone. This public key shared can be shared to anyone, but this private key is very confidential. So this thing is confidential. And same for the user, this thing is confidential. Confidential. And it is not sent to the web server, and web server will never send this private key to the user. So why we created this public key and private key on both the places? Because we need to send data in some encryption. When user want to send data to the web application, that data need to be encrypted, and that encrypted data will be transferred to the web server. So let's create this user is sending some data to web server encrypted. Encrypted. So this encryption mechanism can be Chacha 20, or it can be two fish. There are multiple algorithms to encrypt the data which you want to send to the web server. So how this mechanism will reach to the web server, that how this user will notify that, hey web server, I'm using these encryption to encrypt my data. Because if let's say there is one hacker who is watching my communication between the user and the web server, and they will get that, okay, if I send any data which is provide the details of like which encryption mechanism I'm using to encrypt my data, then this hacker will collect that encryption mechanism, and whenever try to send the data to the web server, it will use that encryption mechanism to decrypt my data and use it for the wrong purpose, and which I do not want ever. So here comes the concept of this symmetric encryption. Okay, so it is the symmetric encryption. So what is symmetric encryption? It means user is sending data to the web server in some encrypted mechanism, which are most of, like, there are many algorithms for it, and user is sending this encrypted message to the web server, but also it need to provide that which mechanism it is sending to the web server. So now here comes the role of private key and public key. Okay, how it will use the private key and public key. So for that, now comes the mechanism of asymmetric key. Asymmetric encryption. First, we will understand that how this asymmetric encryption happen, and then we will go inside the detail of it. So here is the user, here is the web server. First of all, with this asymmetric encryption, asymmetric encryption, user will send that, okay, I'm going to use two fish algorithm. And after, when this algorithm is transferred to the web server, now comes the part of symmetric encryption and data transfer. Data transfer. So now user and web server can send or receive data from each other with the symmetric encryption, because now the web server knows that which symmetric encryption the user is using, and I can use the same encryption method to decrypt the data which user is sending and use it for the application. So this asymmetric encryption happened only one time, one time, and this symmetric encryption happen all the time whenever the data is getting sent over the internet. Okay, so how this asymmetric encryption work and how it is sending the symmetric encryption algorithm to the web server using the public and private key. Okay, so okay, now what I will do, I will just go right. Fine. So how it will do these all things? So first of all, mhm, here is the user, here is the web application, and we will see each step one by one. So first of all, here it have the public key, private key, and web server also have its public key and private key. So web server send its public key to the user. Okay, public key is now with the user. Now what user will do? User will encrypt the encrypt public key with symmetric key algorithm algorithm data, and it will send this encrypted data to the web application. Now it is the encrypted data to the web application. Now this web application have this private key, and there is a mechanism, and that mechanism can create that mechanism can produce that using the private key we can segregate the public key and asymmetric key with the help of private key. Private key will come to the rescue, and it will again differentiate the public key and asymmetric key. So now at the at the place of web application, this web application know that okay, this is the asymmetric key. When this encryption happen at the user side, at the client side, even the user cannot decrypt the encrypted data, because this data can only be decrypted by the private key which is related to the public key. And this private key and this public key was of the this public key was of the web application, and this web application didn't share the private key to the user. It only shared the public key, and this public key was encrypted with the symmetric key, and it cannot be decrypted by the user itself, even the user try to decrypt it. So it will send the encrypted data back to the web application, and this web application use the private key to decrypt this encrypted data, and it will differentiate the private key and asymmetric key. This asymmetric key will contain the data of that algorithm which the user will use to encrypt its data. Okay. So now we can understand that why we need the public key and private key at both the ends. Actually, it was not used like this private key was not shared to each other, because if you share the private key to the web application, or web application will share the private key to the user, then they can modify the setting of your system, and it is totally wrong. It should not happen. It should never happen, because you should not provide the access to anyone. because it might be possible there are thousands of people who are working for the web application, and if they can get access to your system, they can steal the confidential data like your username, your password, your bank IDs, your photos, and that is not good. So that is why we do not share the private key. We only share the public key. And in this mechanism, this private key is used to decrypt the data. So currently, with the help of asymmetric encryption and symmetric encryption, this web application know that what encryption we are going to do, and this user is there who is ready to send the data. But still, there is a one concept which we didn't handle till now, and that is these all things will not provide the HTTP to HTTPS. It is just for the surety between the user and the web application, that they both are in same page, that they know that what they are sending and how to decrypt it. So whatever the mechanism which we did here for the user to web application, it will happen same from the web application to user when web application want to send some data to the user. Okay. So here comes the part of SSL, this SSL certificates. And because of these SSL certificates, your HTTP is coming as HTTPS, and how these things work. Okay. So let's say here is the user again, and here is the web application, and user is sending some data to the web application. Let's say it is some bank portal. It is some bank portal. And there is the hacker. Hacker said that, okay, what I will do, I will create a replica. I will create a replica like it will look same like this bank portal. Like all the elements, all the UI, it will look totally same to the bank portal, and I will send this bank portal address to the user. So whenever the user will go and try to access this www.bank.com, they will open my website which I created. And when this user is going to provide the username and password, as I know that user is connected to my system, I will have the symmetric key, and I can decrypt the data. I can decrypt data and use these credential to empty the account, to steal the money, to empty the account. So how this thing was prevented by the internet? Because it is possible that anyone can create a replica with the same name, and let's say, uh, but it is not good, because these things are very confidential, not for the bank. It can be anything. It can be your Facebook login, it can be your Google login, your Gmail login, anything it can be. Any data which is available to anyone else with bad intention, it is going to backfire you. So how these things were handled? These things were handled with the SSL certificates. SSL certificates, and these are the one which is providing the S in the HTTPS. Okay, so how these SSL certificate actually work? So when the user, so let's say he is the user is going to the browser. Let's say it is Chrome. It can be any browser in its system or in their system. And when this browser is trying to access this www.bank.com, user will notice that it is coming with the HTTPS, and there is one lock sign in the portal. You will see this lock sign in the portal, and you will find this HTTPS prior to the URL of www.bank.com. If this lock sign is there, it means you are connected to the valid website. Because if, let's say, there is a hacker, it is the hacker, and this hacker somehow it purchased the same domain like this www.bank.com. But what this browser do is, this browser have some certificates, and what these certificates are, whenever this bank.com will be connected to the browser, there is one mechanism which will check the certificate, and these certificates are the one which will validate that okay, this certificate have the ID, domain name, and the most important thing, CA sign. What is this CA? It is the certificate authority. It is a very big organization which handle these all uh, which handle these all the websites over the internet. It is very big organization, and I will tell you complete about this SSL certification in too much detail, not too much, but in detail, so that you can understand that what I'm trying to say here. But for now, just try to understand that every browser is contain a list of certificates, contain a list of data, and this bank.com will send these certificate to your browser, and this browser will match these certificate to the certificate which was provided by the bank.com, and it will check whether the CA sign is valid or not. Because if let's say this hacker if let's say this hacker somehow purchased the domain, and if they try to create a HTTPS website, they cannot. Why? Because this CA certificate authority already know that I have issued the certificate to this particular domain, to this organization, to bank organization, for this particular domain, and this guy which is requesting, it is wrong. So I will immediately reject the request of the hacker to provide the certificates. And what then hacker will have? The hacker will have the only option of self signed certificates. So currently, the hacker will have the only option of self-signed certificate. After getting this self-signed certificate, when somehow if this hacker was able to provide you the link of the bank portal with the same domain name, but in the browser, what it will do, browser will have its own CA certificate list. Just think of this CA certificate list right now, and it will get the same details when connected to bank.com. And what it will do the check. This check will happen at your machine, at your browser, at your browser. It will happen at your local machine. So this check will happen, and this browser will reject the hacker's certificate because that is not matching with the certificate. I will tell you that how the browser will have the valid certificates, because there's a mechanism by which these signatures are identified. But currently, let's assume it is the CA certificate list which my browser have, and whenever I'm connecting to any domain, it will ask for the certificates as well. So these certificates are the SSL certificates, and these SSL certificates are signed by the certificate authority, which is a very big company which handle these all the things. And when your browser will get the CA certificate details from the hacker, which is not valid, it will try to match it. It will not match, and it will directly reject it, and it will show that URL as HTTP with the sign not secure. So in this way, this browser is letting us know that yes, this application is not secure. It is might be their certificate is expired. We should not use that. Or it might be possible that some hacker is trying to mimic that website and using their self-signed certificate, because CA certificate authority didn't sign the certificate for them for that particular domain. And due to this, we landed this not secure page. So these all things happen to create your connection in the internet for the TCP, for the TLS handshake more secure. Because, okay, so now let me just go above and clear the screen. Okay, fine. Now we will just go over the one last flow. Okay, so here is the user, here is the web application. So first of all, this TCP handshake happen, which will create the pipeline between the user and web application. Now it's the time for the TLS handshake. TLS handshake. In the TLS handshake, what it will do first, at the user side, it will create the symmetric key. It will send this symmetric key to the web application. This web application will use the private key to unlock the public key, to unlock the encrypted public key and get the details of symmetric key. Why this user and web application, they both will have the public key and private key. This web application will send the public key to the user. User will use the symmetric key to encrypt the data, to encrypt the public key, and this public encrypted key will send back to the web application. Then the application will use the private key to uh, to fetch the details of the symmetric key. Right now, this web application and user, they both know that which encryption will be used over the internet to send the data. Now we need to secure the pipeline. We have the encryption of data. Now it comes part of SSL certificates, SSL certs. These SSL certs are the one which is making your HTTP to HTTPS, H to HTTPS. And how these SSL certs are doing it, because for each domain, these SSL certs are there, and your browser is the one which will do it, which will do it. So right now we understood completely about the uh, TLS handshake, the TLS handshake which is happening for the TCP. In the next part, I will tell you about the TLS handshake which is happening for the QUIC. But before that, let's go back to the questions which we saw earlier, and we will try to answer few questions whatever are available here, like this 1 2 3, and this 4 and 5 are for the QUIC. So first, let's see, why does TLS use both asymmetric and symmetric encryption? Why not just use asymmetric encryption for the whole session? This asymmetric encryption is very process intensive. This asymmetric encryption happened only one time to just provide the detail of symmetric encryption, and at both the end, the user and the web application. And this is why we are using this both asymmetric and symmetric encryption. Do not go for the bookish language. Just try to explain or try to understand whatever you understood till now by the video. A man in the middle attacker intercepts the connection, blocks the server public key, and sends their own public key to the client. How does the browser know it's being tricked? As I told you in the last part, that the not the last part, in the last topic, that there are these SSL certificates which are verified by the browser. So browser have its own list of uh, SSL certificates. Actually, browser do not contain all the SSL certificates. It do one mechanism, but that we will understand in the next part. But right now, just understand this. Uh, Browser will do all the process of matching the CA certificate signature, CA authority signature with the available CA certificate authority signature. And when it matches that, okay, this certificate authority is the one which issued the uh, signature, then okay, I'm giving it clean access that it is, yes, uh, it is legal website. It is not getting, I'm not getting tricked. Okay, so walk me through the round trip time latency of establishing a secure connection using traditional TCP and TLS 1.2 versus modern QUIC. Let's use this 3, 4, 5 for the next part, because these all things are connected to each other. So thank you. Thanks for watching. And let me know if there's any issue in the understanding of this concept. I tried my best, but still, I think that there are some things which are not still clear. But those, all the concepts will be clear in the next 3 parts, because we are going to finish this TLS, TCP, QUIC, CA certificate, SSL certificates, and also the difference between the HTTP 1, 2, and 3. After understanding these all things, we will have one clear picture that how the internet work and how my application should be designed, that it can provide the maximum speed, it can provide the maximum security. So thanks for watching. And if you like it, then share and subscribe it. Thank you.